That would be a good thing to record us. Okay, there we go. We're live.
Just FYI, we have been talking, so whoever's watching this now, this isn't the beginning.
Yeah.
Did you hear about how there's some creepers that are creeping on people?
No.
I guess that there's some guys that are going in to some of the female class members' profiles and watching their group meetings.
Okay.
Don't ask me why they would do that.
I would like to think I've got more to do in my life than that, but
I know, right?
you're watching girls talk about math. I see
It's so exciting. All right. So, what's the research question? Number one.
that. Is the mean age at death different from any of the categories of writers?
Okay.
Right?
Now, in this, I'm assuming that we're going to use the this new hypothesis test, the ANOVA.
Yeah.
So in that case, our null hypothesis is that all of the means are equal.
Mm-hmm.
Okay. And then our um, alternative would be that they're not all equal, or that one or more is different.
Mm. Yes, that's
Okay.
correct. Sorry, I'm still trying to get into stuff. Oh.
Sorry, I'm feeling like doing.
Yes, all means are equal. One's a difference.
Okay.
Collect the data. I don't. I would say they just looked at death certificates for North American authors. I don't know.
I guess we're not given that information. Um,
No.
so, I mean, do we just say that we don't know how the data was collected, but we know that it's from North American female authors?
Sounds good to me. Let me.
Let me consult the key. It says we do not know exactly how the data collected. We only know they looked at the ages. Oh, okay, that works.
Okay. Okay. I think I'm ready with SPSS when we get there. Describe the data.
Okay, so we're gonna want.
So we need to run the data through.
We're probably gonna want the mean, standard deviation, sample size.
Yeah.
I wonder if there's anything else that we should include.
Well, I'd also use mm, like a histogram or something,
Oh, okay.
because I think that's what's going to really tell us if it's uh, way off.
Okay.
Let's see.
Okay.
Uh,
So to do this, we're gonna want to go. We're gonna want to explore it first, or just do compare mean one way ANOVA. Okay, I missed something in the reading.
oh, okay. So we're trying to see if there's a difference in the three. Okay, so what I would do is it looks like it's already separated into group 1, 2, and 3, so we don't need to change that. So we'll want one-way ANOVA, like you said.
Okay.
Okay. We're going to bring over age, right?
Yes. So age, I think, goes on the top box, and then
Type is our factor.
yeah.
Okay. That looks weird.
What does?
Have you gotten your answers yet? I think I goofed somewhere.
Yeah, I did. I got. Let me see. It changed on me. So there's three different sets of. Do we need all three different sets, or do we want the total on the descriptive portion?
Well, I think we want the 3. Let me see if this. Okay, that makes a lot of difference. Well, because I hadn't hit descriptive, and so
Uh,
I just had the ANOVA where it was sum of squares and all that sort of stuff. I was like, that doesn't make sense. Okay.
Don't know.
Cam.
Where's your bunny? Oh yeah.
So
so
okay.
we
On
do
one.
want all four of them.
Okay. Well. So
Nice. Found out how to copy it all as a table. So I'm just comparing mine with what is in the key,
uh-huh.
and it looks right.
Okay.
Do you know how to do a box plot for them?
Yeah, you go to what is
I think if you go to the explore function,
it? Mm-hmm.
and then you just do basically the same thing, but for the factor list, put in type. That way it'll give you three separate ones. So that's kind of nice.
Okay. Well,
Okay.
okay, so basically that's time. What type of hypothesis test is appropriate?
And the ANOVA?
Yeah, because we're dealing with more than two means. And are the requirements test for this? Are the requirements meant for this test?
Yeah, well, they're all normal. I just checked that with QQ plots,
Okay.
and they all have a normal distribution. The other requirement was that the variances are equal. Is that right?
Mm-hmm.
Okay. Oh, but it's a weird type of. Oh.
Okay.
Do you remember what the rule on the variance is?
It was 4 times something, right?
Okay. So if the largest variable, I'm going to write this down, so hopefully I'll remember it. Maybe. So the largest variance is less than or equal to 4 times the smallest variance. Then they're equal. Which, okay. And in this case, our largest variance is 299. Is that what you have?
Mm-hmm. That's what I'm trying to figure out where they're at.
It's in the descript. So if you do the explore function and you do the descriptive, make sure that the descriptive things are in there, then it's intermingled in there.
Oh, there we go. 299.19, is that what you have?
Yeah, that looks like the largest one.
Okay, now I just flipped to the answer and it says 299.186. Do you know what would make that different?
I don't. Hold on. Let me look at the question again. I might have. Okay.
I mean, we're real close, but that's not good. If they ask that question on their homework, we're...
I don't know. And then that second number that they have to
is 170.354, and we came up with...
170.342.
Yeah. So once again, just right there, but...
I don't know. I don't know. I'll be honest.
Okay.
But they are equal because if you do 170.34 multiplied by 4, our largest variance is less than that.
Okay. So the test statistic...
Okay, so the test statistic this time, is that the F score?
Yeah,
Or
it's
the
supposed to
F?
be F on these. So that should be 6.563. Okay, we got
Yeah.
that one.
Yeah, that's what I have. Okay.
Just follow that. Okay? You're welcome.
And the degrees of freedom, would we say 122 because that's the total?
Well, let me see.
Yeah, I think. Statistics. So they give us 2 different degrees of freedom in the key.
Yeah, it gives us the 2 and the 120. Oh. Yeah, up here it says state the degrees of freedom, and it says we have to use both.
Oh, okay. Okay.
But also the order in which these are stated is important. For an F test, it is not the same to have 2 and 189 degrees of freedom as it is to have 189 and 2 degrees of freedom. So I guess we'll have to make sure we do them in the right order.
Do we just do smallest to largest, or?
I think we do the between groups and within groups.
Okay.
But
Okay. Sounds good to me.
Let's see. Compute the p-value. That's 0.002, right?
I think so. We don't have to divide this one in half because it's not two-tailed, it's just one-tailed, right?
Right.
Okay.
Well, it's yeah. And then we'll reject the null hypothesis, right?
Because our p-value is so much less than our...
Is less than alpha.
Yeah.
So then we can basically say we have evidence that poets die younger. Is that our conclusion?
Well, according to the means, yes, but I feel like the conclusion that we've reached so far is just that they don't die at the same age.
Okay.
So, I mean, based on the means that we've calculated,
Okay.
then yeah, poets die younger. But at the same time, we have a lot less poets than we do novelists.
Okay.
So,
So we have sufficient evidence to say at least one of the mean ages of death of writers is different from the rest of the mean death ages for the other categories of writers. So I guess, like you said, they're different.
okay.
But then take action. It basically says that it brings in that the poets die younger, and we need to provide them better mental health care. Okay. I don't know.
Yeah, those writers need that, right?
Well, I'd agree, but I mean, I don't know. I'm kind of a evidence guy, so what's to say these young poets didn't die in car wrecks? You know what I mean?
Uh-huh.
I mean, that's kind of a reach. I don't know.
Yeah, I don't know. I do kind of laugh at the one in the key. Maybe our poets just need another job too.
Maybe.
Ever heard the term starving poets? Maybe they're just a starving poet.
Okay, let's see if I can get this to load right.
On to the quiz.
Sure.
Man, we're making record time tonight.
Got It's perfectly fine with me.
Same here. I didn't even get kicked out of iLearn yet.
Yay!
Oh, we have
Okay,
an
well,
exam this week.
oh, yay! It's not so much review for the exam.
Yay, right?
Sure. Okay.
Well, it doesn't say that we need to have any data files, so interesting.
Mm-hmm.
I guess we'll find out.
Okay. And in a novel hypothesis test, we reject HO when there is sufficient evidence to indicate at least one mean is different from the others. True?
I think so. Yeah. Because that would be our alternative hypothesis. So what requirements need to be checked when performing an ANOVA hypothesis test? Normally
It's going to be B and C. Data in each group are normally distributed, and variance
are equal. Well, it doesn't say B and C. That's just the second and third options.
Well, yeah.
Hopefully, it is B and C.
Check if each group is normally distributed. Do the following.
QQ plot.
Yep.
We assume the variance in each group is the same if the following happens. The largest variance is less than 4 times the smallest.
Yep.
I feel like that's a weird rule. But I don't understand statistics either. Hypothesis test. It's conducted 2 sample test for every pair of samples. There are 3 samples. There are 3 pairs. If there is 4 samples, how many pairs are there?
I'm going to say 6. You have 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and then 3, 4.
So 1, 2, 1, 3, 1, 4, 2, 3, 2, 4.
And then 3, 4.
Oh, okay.
So would you say 6?
Yeah. Soccer shoes, data, soccer shoe data. There's 6 groups, A, B, C, D, E, and socks. Okay. This data can be found in the wiki. Load all 6 samples. So we do have to get a data file.
Socks?
I wish that they would say in that little screen before the quizzes everything that you need. All the data files that you need to download.
Okay. Socks.
Soccershoes.sav. Okay.
What?
You find it?
Soccer shoes. Okay. Okay. You know, I have one question. And it's something I've thought about while I'm waiting for this to load.
Okay.
I wonder what makes this biostatistics over a different type of statistics, because so far I haven't really seen a, you know what I mean?
I know what you mean. I was actually just talking to my brother about this today. They're like, what? How come biostatistics and business statistics are different classes?
I mean, so far we've done statistics. I haven't seen anything that
Is
would
specific
make,
to
yeah,
biology.
would make me say, oh, okay, that's why this is biostatistics versus the other statistics classes.
Yeah.
Um,
Wait. There is one thing. The
hmm?
pictures at the beginning of the lessons.
Oh, okay.
I,
Maybe
I
when we
think
get onto our group project, it's going to be specifically about biostatistics or something.
maybe. Is that what was said?
I don't know. He sent out an email today about group projects. I hadn't looked at it really yet. I'll
Yeah, I
probably look at
haven't.
it when we're done.
So I don't know. I'm
Probably-
kind of hoping he doesn't watch this because I feel really guilty. But in my course feedback, my mid-course feedback, I gave the feedback that said he should do his videos earlier because by the time he usually does them, we've already got half of the week done.
Hmm.
He he did the video earlier this week, and I haven't watched it yet.
Maybe he got your feedback.
Yeah, that's what I'm thinking, but now I feel bad that I haven't watched it yet.
Okay, so
Oh, okay, so we're supposed to do a Nova test.
okay. So do we have to switch socks ECBA? We need to transform those, right?
Yeah, we do.
Automatic recode. Okay.
And it just says on the question to do your ANOVA test and observe that the p-value is 0.0809. So they've already given us that. Then we're just supposed to remove the socks from it.
Okay. Okay, well, mine must round because mine says it's 0.081.
That's what mine said too.
Okay. So if we remove socks from the data, which how would we do that? Just go in.
I just went into the data and selected those rows
Uh-huh.
and cleared them. I just right click and then there's an option for clear.
Mm,
And then I just did the ANOVA test again.
okay. So now I got 0.309.
That's what I got too.
Okay. 0.309.
I'm not really sure if I understand what it wants us to do next.
Okay, so I guess we have to go through and remove each group one at a time and run it.
well, hold on. Do we remove each group until we're left with one, or do we just remove one at a time and see what it is? So, like, we always have
I'd
five.
say one at a time because it says what is the highest p-value you see when removing only one group.
So we want to make sure that we have 5 groups each time we remove a group, right?
Yes.
Okay.
5.309.
Isn't this the funnest thing ever?
Okay. So do we want to remove E first?
That's what I've done, and I've just been working my way up.
Okay.
And so far, it looks like the next question, that true or false, is a false, because the p-value when you remove E is 0.05.
Okay. Come on.
Okay. Last one. Okay.
I'm coming, I promise.
Oh no, you're good. I started, I think, sooner.
Okay. Come on. Arlen is being stubborn.
It's been doing that all day.
Okay, so yeah, that would be false. And then highest variable I got was 0.448.
Same here. Mm. And then the next question is asking about the variances, the largest and the smallest. That's what the next two are. And while you're in there doing the descriptive statistics, it might be good to construct QQ plots too, because that's the next questions it asks after the variance.
Okay. What did I do?
Don't you love statistics?
Okay. Dependent list is, what did you put in for dependent list? Because I think I did it backwards.
I said, so under explore, for a dependent list, I did kicking accuracy, and then for factor lists, I did the one that we did the automatic recode for.
So dependent list, you did kicking accuracy, and then factor list was that one. Okay. Well, my smallest variance that I can see is
The smallest one I saw was the third one.
eight.
27.208.
Yep.
Okay. And then the largest one was 53.158, which was the fourth one. Or root D.
53.158.
Yep. And then
Yes. Right?
yes. True. So on question 13, that whole the largest variance has to be less than 4 times the smallest variance. I feel
Yeah.
like that almost is always going to be the case. Because, I mean, unless you're, in this case, if your smallest variance was 10, then it wouldn't be true, but yeah.
Okay, I'd say your QQ plot's pretty,
Pretty normal.
yeah.
That's what I thought too.
The test statistics for ANOVA hypothesis is an F statistic. Is the p-value the area to the right or left of the F statistic?
To the right?
Yes.
Okay.
That's what it looks like.
All right. I'm going to submit it.
Yay!
Woohoo! I love 100%.
Yay.
Cool.
Alright.
I will see you on Wednesday to review the test stuff.
Okay.